Taking a while to warm up. Here we go. All right, chapter 3 review. For your chapter 3 test tomorrow, you will have 6 questions. 6 questions. The majority of them are going to be graphing problems, and we'll talk about what kind of work I'm expecting to see there. Essentially, you're going to be creating XY tables, and then you're going to have a couple of problems that are a little bit different in nature. The first problem that you have is a little bit different than just a graphing problem. You're going to be interpreting a graph. So from section 1 notes, so if you are keeping this cheat sheet going, this is a problem that is written in our section 1 notes here on graphing ax squared. It's going to be this problem right here. So in this problem, we're not asked to graph at all. We're simply asked to determine characteristics of a given graph. And so on your test tomorrow, you're going to be given some sort of graph. This is what we had in our notes. And you're going to be asked about a series of key terms, a series of attributes, some characteristics about this shape. Okay, so in section 1, it was really an introduction into the types of shapes of a quadratic that resulted in what we call a parabola, or this U shape. And so these characteristics are common terms that are dealt with these kinds of functions. And so you're going to get a problem that's going to ask you about these things. And so I'm mostly just going to break down what kind of answer is being expected here. So first things first, vertex. This is a term that we've dealt with quite a bit throughout this chapter. The vertex is the extreme point of a parabola. Namely, it's going to be this point. So in a happy face parabola, it's this minimum value. If this had been reversed and it was, say, a sad face parabola, then it would be considered the maximum. But it's going to be the critical bend part in the parabola, right? And the important thing to understand here is when it asks you for the vertex, that is a coordinate point. So again, if you're doing this in your cheat sheet next to the vertex, this is going to be an XY coordinate point, right? And so I just have to identify what that coordinate point is. So in this case, I would have to have gone left 1, down 2. So my coordinate point for this problem for the vertex would be -1, -2. Okay, so vertex is identifying that coordinate point. AOS is just how I abbreviate it. AOS stands for axis of symmetry. Axis of symmetry. The axis of symmetry goes through that critical point, through the vertex. It's going to be basically what chops this parabola in half. Okay, it's the vertical line in this case that chops this parabola in half. And the nice little shortcut for the axis of symmetry and how to identify it is it's going to be whatever the x value was for that vertex. So in this case, the axis of symmetry, or that vertical line that chops it in half, is the vertical line that goes left 1. All right. So again, if you're doing this in your scratch work, the vertex is going to be a coordinate point. The axis of symmetry is going to be an equation of a line. Okay. And so for axis of symmetry, it's going to be x equals something. The reason why it's x equals something is because x equals any number is a version of a vertical line. And then the number that it equals just places where that vertical line goes. And so in this instance, the vertical line would be placed at -1, all right, because that's what's going to pass through the vertex. So in this problem, the axis of symmetry is x equals -1. And for your test tomorrow, your axis of symmetry is going to be x equals whatever value chops that parabola in half. Domain and range are terms that we have covered in previous chapters as well. Domain refers to possible x values, or another way to describe it would be how far left and how far right the visual graph can go. Now, again, here's a nice little shortcut, nice little spoiler for you regarding domain. Domain for your parabola tomorrow, this will be an automatic free point. Domain for tomorrow will be all real numbers. Domain will be all real numbers. What that literally means is that there is no limit to how far left or how far right that this graph can go. There is no limit to the x value that can go into whatever quadratic function you have. Range will be a little more interesting. So if domain is possible x values, range is possible y values, or visually speaking, it's how far up the graph can go or how far down the graph can go. Now, in this case, this parabola obviously goes forever upward. We can see that with these little arrows. But downward, the lowest that this graph goes is right here at its vertex point, right? That's the lowest point of this graph. So the range in this case, the range for your test tomorrow is going to be y compared to some number, but we're going to be using an inequality. So your range is either going to be greater than or equal to something or less than or equal to something. It depends on whether it's happy face or sad face. This one being a happy face parabola, y is going to be greater than or equal to this minimum value here. And when I'm talking in terms of y, the lowest that this y value goes is -2. So in other words, another way to describe that with an inequality would be to say, for this problem, the range is y is greater than or equal to -2. Had it been a sad face parabola, then it would be less than or equal to, because it'd be everything below that point. So just be prepared for that as well. Increasing and decreasing increments have to do with if you read it from left to right like a book, right? Reading it from left to right like a book, kind of like the slope of a line. If it's increasing, it's going to be going up. So the right-hand side of this parabola, the right-hand half of this parabola is what's the increasing half, whereas this left side of the parabola is the decreasing half. Had it been a sad face parabola, those roles would have been reversed. But what they're looking for the increasing and decreasing values, now it's going to be x's that we're going to be comparing. So increasing from this vertex forward, it's increasing. So I would say x is greater than -1 for the increasing increment. For the decreasing increment, it's just the flip side of that same inequality. So now it's x is less than -1. So it's everything to the left of that point. Okay, so you're going to get a problem like this on tomorrow's exam. It's basically just these key terms. All right, so let's move on. All right, from section 2, now I'm going to jump onto the whiteboard. That one was just a little tedious to try and draw on the whiteboard, so I figured I'd skip that. But now from section 2, you're going to have a single problem from section 2. In section 2, now is where you're going to be asked to graph things. Now is where you're going to be asked to graph things. So for these next several problems, section 2, this is the only one from section 2, you're going to be asked to graph a given function. It will be a quadratic. It will produce that U-shaped parabola. That's going to be the spoiler alert. But when I'm asked to graph, you're going to see different forms of that function. So this function is taken directly from section 2 notes. You will see something similar to this for your second problem tomorrow. All right, so this is definitely a quadratic. It's going to produce that U shape. I know that because this x squared is my largest degree term in this polynomial. All right, and the reason why we can identify this as section 2, because in section 2, I had ax squared plus c. It was basically a 2-term polynomial where I had my x squared element, and we learned what c did to the shape of that graph. All right, technically there is an a in front of this x squared. That a just happens to be 1 in this case. So there is still an a, but yeah. All right, so I'm asked to graph this function. So let me jump right to what I'm expecting from your scratch work. All right, so from your scratch work, this is what I'm looking for. Anytime you're going to be asked to graph something, I'm going to be looking for an XY table. So for an XY table, or XG of X table in this instance, okay, you can use the letter Y. That's totally fine. All right, let me slide this down a little bit more. All right, there we go. All right, so for my XY table, my job for any XY table is to essentially do the same thing, which is I need 3 coordinate points to plug into this function so I can get 3 coordinate points, right? So I need 3 X values, pardon me, to plug into this function so that I get 3 coordinate points on the other side of this. And the reason why I need 3 is because in order to draw the shape of a U, I not only need to identify the most critical point, the vertex, but I want to be able to identify something on either side of that vertex as well. So I get that U shape. Okay, so the trick here becomes, what values do I plug in for X? Now, I'm going to go ahead and give you the values for this kind of section problem. So in section 2, for this kind of quadratic, you're all going to put down the same X values. and they're going to be these: 0, -1, and +1. Okay, so for your second problem, these are the values I'm going to want you to plug into this equation, basically, right? And the reason why I know that my vertex is going to be centered at 0 is because there's no bx term in here, meaning that axis of symmetry is going to be locked onto the y-axis. Okay, that for us, that means that the vertex is going to have a 0 coordinate value for its x, right? But in short, for your guys' sakes of the test tomorrow, these are the values I want you to plug in. So this is the work I'm expecting. You're going to be showing me the work for plugging each of these values into this function. So I have x squared, and x is going to be the thing I'm going to be replacing. All right, I'm going to have x squared minus 3 for my 3 separate values. And what will happen is as I plug each of these values into this spot for x, it's going to do stuff to it, and it's going to spit out a y value, and I will have created coordinate points. So when I plug in -1, negative goes in the place of x, 0, and 1, right? Each of these values came directly from the x values plugging in. So now I'm doing the work. Now, if you need to show more than these steps, this is essentially what I'm looking for like demonstrating like where the things came from. If you need to show more work, like if you need to show me like -1 squared is +1, kind of like I do on my solutions that I've uploaded to Google Classroom, my next step here would say +1 minus 3, and then I would be able to get to my result. If you need that, then write as much work as many steps as you need. For this, I'm okay with you going from this and jumping right to what the solution is, because it's basically a 2-step problem. Deal with your exponent, you'll get a value, subtract 3, you'll get your answer. So in this case, what I'm going to get, -1 squared is the same thing as saying -1 times -1. That will give me a +1. So this result here is +1 minus 3 is going to give me -2. And what I've just created is a coordinate point, -1, -2. Going to do the same thing for 0. When I plug 0 into this equation, 0 squared, again, if you need to show your work, this element right here would be 0. I would subtract 3. My ultimate answer here is going to be -3. This one ends up being my vertex, 0, -3. When I plug in this 1, now one thing that should happen here is because this is my vertex, these 2 values here should end up being symmetrical. So my result here should also be -2. But let's go ahead and go through the math anyway. 1 squared, or 1 times 1 is 1. That 1 minus 3 does in fact give me -2. We've just created 3 coordinate points. Namely, we've created the 3 coordinate points needed to create that U shape. This is the scratch work I'm expecting to see for my graphing type problems, my XY table for 3 different values. At this point, you would have your test tomorrow is going to be on big ideas. So you're going to have a multiple choice for the actual graph selection. You're just going to look for this combination of coordinate points, and that will help you with which answer is which. But that's the scratch work I'm expecting. So let's move on to the next. Now we're going to still be asked to graph. This is now just going to be from another section. So now we're going to do a problem from section 3, and you're going to have one problem from section 3. So again, you'll be asked to do the same sort of thing, which is to graph, but now this is going to be a section 3 problem. Namely, it's going to involve a little bit more terminology. So this one was pulled directly from our section 3 notes. We're given the following function: 3x squared minus 6x plus 5. All right, so in section 3, we were introduced to ax squared plus bx plus c. All right, so it's just a little bit longer polynomial than the last one. And again, the useful thing to identify here that we learned in section 3 are these coefficients. This 3 is the a coefficient. This -6 is the b coefficient, and +5 here at the back end is my c coefficient. We'll deal with the a and the b for this solution. But again, my task here is the same. Graph this quadratic function, this U shape, this parabola. So this is the type of work that I'm expecting. Let me go ahead and scroll this down a bit. So again, since I do have to graph, I am expecting an XY table, and I need 3 values. All right, so I need 3 values to plug into this function. Figuring out these three values, again, the three values, I need to find the vertex, and I want to point on either side of that vertex. That way I get my symmetrical U-shape. So how do I identify the vertex here? Now, unlike the last problem, there is not necessarily a set value to plug in for my vertex. In the last one, I could get away with that because there was not this B term, this BX term here in the middle, right? So how did we solve that? In section 3, we learned this little mini formula to help solve with that. Negative B over 2A. Negative B over 2A. The purpose of this little mini formula in section 3 was to help us identify where the axis of symmetry is, the line that will chop my parabola in half. So that B and A come directly from these two coefficients. I just have to be careful with things like this. That negative sign is attached to the 6, so don't lose track of that. But I'm going to use this to not only find the axis of symmetry, that value that I'm going to get from this negative B over 2A is going to end up being my middle value on my XY table, my vertex value. All right, so plugging stuff in, all right, so plugging in here, I know I'm going to have a negative B, whatever B is, over 2 times whatever A is. Let me replace those things now. So B here is negative 6. So I purposely wrote the negative twice because that's going to end up canceling and making it positive. 2 times A, well, A here is this positive 3, right? And so now I just simplify this, right? Well, negative 6 is the same thing as positive 6, right? 2 times positive 3 gives me, again, a positive 6. I have this fraction result, but this can simplify. 6 over 6 reduces to 1. What do I do with this 1? This 1, again, represents the axis of symmetry that will, whatever this looks like, it's going to chop it in half. So that would be a vertical line located at positive 1. So if I had my axis of symmetry, I'd go to the right 1 to identify where that would be. But more importantly, for my XY table, it's going to tell me where to locate my vertex. So that vertex is going to end up being my middle value on my XY table. So negative B over 2A, whatever result I get is going to be used for the middle value here. It's going to ultimately be my vertex. Now, how will that also help me? Now I can pick a value less and a value greater than that vertex value, and I'll now be able to create that symmetrical U shape. So it really doesn't matter how far below 1 you go. You could go 5 below it, you could go 10 below it, you could go a single 1 below it. As long as you're going the same amount the other side, that way you create your symmetry. So for me, I'll just go 1 below. That's typically how I do it. So 1 below 1, or one thing less than 1 could be like 0. A number greater than 1 could be 2. But again, as long as I'm symmetrically far apart, it really doesn't matter. Okay, but now at this point, now that I have my 3 values, it's exactly like the last problem. You're plugging each of these 3 back into the original. And so this is the work I'm expecting. 3 times x squared, I'm going to end up replacing that x, minus 6 times that same x, and then plus 5. I'm going to be doing that same exact work for each of these x values that I've created that I have not chosen randomly. We use that negative b over 2a to identify where to kind of center those values. But basically, each of these x values are going to be plugged into each of the same equation. So 0 goes in the place of x up here, 1 goes in here, 2 goes in here, or whatever values you end up determining. Okay, so one thing to point out tomorrow, this triple of x values worked for this problem because of the negative b over 2a. This trio of numbers may be completely different for your test tomorrow, depending on what b and a are. All right, just be prepared for that. At this point now, it's just order of operations. Okay, deal with your exponent first. So if I were dealing with that here, let me do the slightly more complicated one just to get it out of the way. So 2 squared is what I would do first here. 2 squared is 4. All right, so that 4 now would get multiplied by that 3 in front, and that would give me 12. So here's a quick way that you can kind of show some work. And just like really small numbers, I'll write like what each term is at the bottom. So 3 times 2 squared will end up giving me 12. Over here, negative 6 times 2 will end up giving me a negative 12. And then the plus 5, nothing special happened there. That stayed exactly the same. But now I have my little arithmetic sentence right here. So 12 minus 12, that cancels out. That gives me 0. But that 0 plus 5 ends up giving me positive 5. And what we've just created is the coordinate point, 2, 5. For 1, now we'll work through this a little bit faster. 1 squared is 1. 1 times 3 is 3. This result here is 3. Negative 6 times 1, that's minus 6. And then plus 5. 3 minus 6 gives me negative 3. That negative 3 plus 5 gives me positive 2. There's my vertex point. Here, 0 squared is 0. 0 times 3 is 0. Negative 6 times 0, well, that's still 0. And then plus 5, that's going to give me 5. And it makes sense that these two match because, again, I should have symmetrical values on either side of the vertex. And my triple of points give me something to look for in my multiple choice graphs. So that's how I would deal with this ax squared plus bx plus c type of graph. All right, let's keep going. That's the scratch work I'm expecting for that one. On your test tomorrow, you'll have one more graphing problem. All right. So this will now be from section 4. Section 4 is where we introduce the first different rearrangement of a quadratic equation. Namely, we learned vertex form. So this one was pulled directly from our section 4 notes. You were given this function to graph. Negative 2 times x plus 2 quantity squared plus 3. So the signature look for something from section 4, this vertex form, was I had a parentheses squared. All right. So on your 4th problem on your test tomorrow, you're going to be seeing something similar to this. It'll be different numbers, but it'll be a vertex form of a quadratic. It's still a quadratic. I still have an x squared in there. And so it's still going to have the same sorts of shapes, right? So the important thing to understand here in this one is to be able to identify h and k. H and k in the vertex form will literally give me the vertex. Tricky thing here, and if you need to make a note of this in your margin, please remember that whatever's inside the parentheses, I'm going to end up taking the opposite value. So the fact that this is a positive 2, my x value from my vertex point is actually going to be negative 2 for this one. And then I keep the same sign for this guy. So the important thing to understand here is that my vertex, let me use a different color. How to interpret my vertex form? Well, it's kind of important to be able to pull out what my vertex is. My vertex in this case comes from the opposite of the value inside the parentheses, or had I set the parentheses equal to 0, solve for x, and then the same sign for whatever's outside right here. In this case, my vertex is going to be a negative 2, again, the opposite of the sign here, and then the same sign here for my y value being positive 3. And that, again, comes from my h and k. All right, so learn to identify those. Please be aware, again, it's going to be the opposite sign of whatever's in here. Or another way to think of it is I take the parentheses and I set it equal to 0. X plus 2 equals 0. If I subtract 2 from both sides, I get x equals negative 2. All right, but again, because I'm asked to graph, my work consists of the same exact things as the last couple problems, right? So in the last couple problems, I had to create an XY table. And it'll be the same thing for this one. And just like the other ones, I need 3 values here, right? So again, I have to determine what x values I'm going to plug in. This is not random. Because I've just identified the vertex, that ends up being my middle point. And because I already have the coordinate combination, I can plug that in directly into my XY table. And there is my vertex. Now, I could go through the process of taking the negative 2, plugging it in for x. I would find that negative 2 plus 2, that goes to 0. 0 squared is 0 still. That 0 times negative 2 is still 0. And that 0 plus 3 would end up giving me right back to this 3. So that's why it does what it does. But more importantly, just by identifying it in the equation, I'm able to immediately fill in one of my coordinate points, the most important coordinate point. And then just like my previous problems, I need to pick a value less than that and or left of that on the visual graph, and then a value right or greater than that on the visual graph as well. So number less than -2 would be -3. Number greater could be like -1. These will get plugged back into my original equation. So just like the previous problems, -2 times that x plus 2 quantity squared plus 3, right? Same thing will go for this one. And just like the others, I just have to be careful of order of operations. That -3 is what gets plugged in for x here. -1 gets plugged in there. The evaluation of coordinate points. And so just like the previous problem, I just got to be careful with order of operations. I'm going to deal with the parentheses first. So -3 plus 2 gives me a -1. -1 squared is going to give me +1. That +1 times -2 is going to give me a -2. And then I still have this +3 on the outside. -2 plus 3 gives me 1. And I've just created a coordinate point. Same thing will happen here. And I should get the same exact result because it's symmetrical, but just confirming that -1 plus 2 is a +1. +1 squared gives me +1 again. That +1 times -2 gives me -2. And then still adding 3. And there it looks exactly like the one before, and we get a 1 result, another coordinate point. So this is what I'm expecting for this one. So this one's nice and convenient because I got to skip one of my values because it's literally built into the very equation. Just be careful about the opposite sign here. All right, let's keep going. That's it for our graphs, and you'll notice the same exact thing for each of the scratch work. I need to see the XY table. I need 3 different coordinate point values. All right, so now we're going to do a problem from section 5. This is the longest problem solution-wise of your test. This is the longest solution problem of your test. So I'm going to do this very quickly for the sake of fitting it into the video. You're going to be asked to write a quadratic function, more specifically. Meaning you're going to be asked to write a quadratic, like an x squared, f of x equals an x squared sort of function. And you're going to be asked to do it in standard form. So first off, it's going to be important to understand what standard form actually is. And so for us, that standard form is going to look like this. Y equals ax squared plus bx plus c. Essentially, a sentence polynomial. Kind of like what we dealt with at the beginning of chapter 2. The important thing to understand there is that for this kind of problem, what you're going to get is not currently in this form. So I'm going to have to distribute and collect like terms to result in this, just like we did in chapter 2. So it's kind of like a revisit of that. All right. So I need to write it in the standard form. And then you're going to be given some information. And then you're going to be given this information. This is also pulled directly from the notes. You're going to be given a vertex. You're going to be given a vertex point of some other coordinate point combination. This is the example that was from our section 5 notes. You're going to be given a vertex, and then you're going to be also saying, all right, it's going to contain this other point. All this means, whatever other point that they give you, just means that this point also exists on whatever U shape of graph there is. And in this case, this was not in your notes, so please make sure you're writing this down. So this other point that I'm given is going to be useful in determining an unknown value. Particularly for us, it's going to be helpful in determining A. Okay, so you're going to be given a vertex and some other coordinate point that's part of that graph. So the most important part right here is the fact that I'm given a vertex. Because I'm given a vertex, this is the form that I'm going to want to plug into. I'm going to want to plug into something that is useful with the vertex, in this case, vertex form. Vertex form being this x minus h quantity squared plus k. Now, if I'm taking this vertex and plugging it into vertex form, these values, this xy value right here, are going to go directly in for h and k. So for me, that means that the -3 is going to go in for h, and the positive 4 is going to go in for k. So on my solution, all right, and this won't completely finish it, but on my solution, I'm going to have this result. So after I plug that vertex in, I'm going to get this equation, y equals a. I'm still going to have to figure out what a is. And then I'm going to have x minus a negative 3. Minus a negative 3 is actually going to make that plus 3. Right? And then that's going to be squared. And then plus k plus a positive 4 is going to keep that same sign, plus 4 in this case. And again, where did this come from? This came from that vertex that I was given. So far, I have my vertex in here. Now, in order to be a proper standard form function, I just have y and x that are my unknowns, right? In other words, I need to figure out what a is. Here's how I go about figuring out a. I'm given another point. In fact, I'm giving another x, y coordinate point on this grid. Now, it's not as important as the vertex. The vertex is already spoken for. But this point is what's going to go in for this y and x value here. So to color coordinate this so you can kind of see what's going on, let me change this to green so you can kind of see where it goes in here. All right, so we were given -1, -4 as my coordinate point. I'm going to take these green values and plug them in to this equation. So y is going to equal this y value, -4, right? A, I still don't know. We're actually going to go through the process of figuring out what a is. That's going to multiply times x plus 3 quantities squared, but now x is going to be this guy. X being the -1, the x value in that coordinate point. So that's where the -1, -4 go. It's still plus 3 because this plus 3 was part of the opposite sign of that x value for the vertex. And then the plus 4, again, comes from that vertex point. And what you'll notice is that I have a bunch of numbers and a single variable, meaning I can get the solution for that variable simply by doing the other order of operations, the other calculation. So let's see what happens. As I said, this is the longest problem of the test, so it's not shocking that this is taking a while. But let's keep going. So now I just do the calculations. -1 plus 3 is the first thing I have to do because it's in the parentheses. -1 plus 3 is going to give me 2. That part's going to be squared, plus 4. -4 is still on the opposite side. The piece that I'm still solving for is a. All right. 2 squared gives me 4, right? So I have 4 times that a. All I did right here is I swapped the 4 and the a. Technically, you could have a times 4. That doesn't really matter. And then the plus 4 over here still is the same, and it still equals -4. All right, we're in the business right now of getting a by itself. So now I need to subtract 4 to the other side. If I subtract 4 from a -4, I get -8. And that's still equal to 4 times this unknown a. Now dividing the 4 to the other side, I'm going to get that a is -2. So what was the whole point of plugging in that other coordinate point, that -1, -4 coordinate point? It allowed me to figure out what a is. A, again, determines the shape of my U shape, my parabola. Right, so that -2 value does that. But more importantly, going back to what I have to do in this problem, I need to write this in standard form. I'm going to need this a value to be plugged into that form so that I can get my final result. So let me do a little bit of erasing right now, and we'll go back to solving the actual problem right here. All right, so again, I was given this information, and we've gotten to this point now. We now have y is equal to a, but now I know what a is. A is that -2 value that we just went through solving. And then we had the x plus 3. That plus 3 came from the opposite sign of that x value. And then the plus 4 came from the y value of that vertex. So now this is our vertex form. But keep in mind, we were asked to put this in standard form. So at this point, now that I have my completed vertex form, now I have to go through the process of distributing, collecting like terms to rework this into ax squared plus bx plus c. So now I'm going to take this x plus 3 and multiply it by itself doing the squared action. So another way to rewrite that would be this -2, sorry, and then x plus 3 times x plus 3. That's another way of saying squared. And then the plus 4 on the back end is still there. All right, so this comes from chapter 2, but I'm going to take this x and multiply it throughout that parentheses. Then I'm going to move on to that 3 and multiply it throughout that parentheses. So when I do that, that -2 out front is still there. And when I multiply these together, I'm going to get x times x, or x squared, x times 3, or 3x. 3 times x is 3x, and 3 times 3 gives me 9. That distribution process comes from chapter 2. And again, don't lose track of the fact that I still am adding 4 at the back end. All right, let's keep going. So at this point, now I'm going to be distributing this -2 through multiplication throughout this entire parentheses, and then adding 4 is going to be able to combine with that 9 on the back end, right? But I also can combine these guys. Both of those are x's, right? So first things first, let me go ahead and combine those like terms. So I'm going to have -2 on the inside of this parentheses. This was x squared. 3x plus 3x gives me 6x, and then it's still plus 9 over there, and then it was still plus 4 on the back end. All right, so all I did from here to here is I combined those like terms. All right. So at this point, now I need to distribute this -2 throughout this parentheses. Y is going to equal -2x squared. -2 times positive 6 gives me -12x. -2 times positive 9 gives me -18. Plus 4 still on the back end. These two can combine. My final answer here is going to be -2x squared minus 12x. -18 plus 4 gives me -14. There is my final solution. All right, I am done with time, so let me go ahead and stop recording.